Modern technology has created new contexts for yawn contagion that test the limits of mirror neuron physics. Video calls, recorded media, and even written descriptions of yawning can trigger contagious responses, suggesting that behavioral energy transmission doesn't require direct physical presence. However, the effectiveness of mediated yawn contagion is typically reduced compared to face-to-face interactions, indicating that full bandwidth sensory information optimizes mirror neuron resonance. The pharmaceutical effects on yawn contagion provide insights into the neurochemical mechanisms underlying behavioral energy transmission. Drugs that affect dopamine, serotonin, and other neurotransmitter systems can alter both spontaneous yawning and contagious yawning patterns. These chemical influences reveal how behavioral physics emerges from underlying biochemical energy states that govern neural network activity and social responsiveness. The measurement and quantification of yawn contagion has revealed mathematical patterns that support physics-based explanations. The probability of contagious yawning follows predictable curves based on social distance, attention focus, and individual susceptibility factors. These mathematical relationships suggest that behavioral energy transmission operates according to quantifiable physical principles rather than random social influences. Research into artificial systems that can trigger contagious yawning explores whether technological interfaces can effectively stimulate mirror neuron responses. Virtual reality environments, robotic systems, and computer animations that display yawning behaviors can sometimes trigger contagious responses, but typically with reduced effectiveness compared to human yawning. These findings suggest that optimal behavioral energy transmission requires the full complexity of biological motion and social cues. The next time you find yourself yawning after seeing someone else yawn, remember that you're not just following social suggestion, you're demonstrating Emmy Noether's conservation principles applied to behavioral energy in human networks. Your mirror neurons are functioning like biological resonance systems, maintaining symmetry and conserving energy across social connections with mathematical precision. Contagious yawning reveals that human behavior follows physical laws just as predictably as vibrating strings or synchronized pendulums, showing us that the boundaries between physics, biology, and social interaction are far more porous than we might imagine. In the simple act of synchronized yawning, we glimpse the profound ways that energy conservation governs not just physical systems, but the intricate social networks that define human experience. Age significantly affects yawn contagion susceptibility following developmental patterns that reflect changes in mirror neuron system maturity. Young children under age 4 rarely exhibit contagious yawning, suggesting that mirror neuron resonance systems require significant development before they can efficiently transmit behavioral energy. Elderly individuals also show reduced yawn contagion, possibly due to decreased mirror neuron sensitivity or changes in social attention patterns. Peak contagion occurs during adolescence and young adulthood, when mirror neuron systems are most active and social synchronization is most important. The evolutionary aspects of contagious yawning suggest that it serves important group survival functions that follow energy conservation principles. Synchronized yawning helps groups coordinate sleep-wake cycles, ensuring that collective vigilance and rest patterns optimize survival advantages. Groups that yawn together stay alert together, maintaining coordinated attention states that improves predator detection and resource acquisition. This represents a sophisticated application of behavioral energy conservation that enhances group fitness through synchronized physiological states. Neurological conditions that affect mirror neuron function provide natural experiments in yawn contagion. Individuals with autism spectrum disorders often show reduced contagious yawning, correlating with differences in mirror neuron activity and social attention patterns. Psychopathy is also associated with decreased yawn contagion, suggesting that empathy and behavioral resonance share common neural mechanisms. These conditions reveal how disruptions in mirror neuron physics affect the transmission of behavioral energy across social networks. Cross-species yawn contagion demonstrates that this phenomenon reflects fundamental biological physics rather than uniquely human social behavior. Chimpanzees, bonobos, and other primates exhibit contagious yawning within their groups, following similar patterns and timing as human yawn transmission. Even domestic dogs show contagious yawning in response to human yawns, suggesting that mirror neuron resonance systems evolved as general mechanisms for behavioral synchronization across species boundaries. The brain imaging studies of contagious yawning reveal the neural networks involved in behavioral energy transmission. The superior temporal sulcus, which processes biological motion, activates when observing yawns. The premotor cortex, which controls voluntary movements, shows increased activity before executing responsive yawns. The posterior cingulate cortex, involved in self-awareness and empathy, modulates the strength of yawn contagion based on social context. These brain regions work together like components in a resonance circuit, amplifying and transmitting behavioral signals across individuals. Environmental factors also influence contagion efficiency, following physical principles that affect energy transmission. Fatigue increases susceptibility to contagious yawning, possibly because tired brains have reduced inhibitory control over mirror neuron responses. Stress and anxiety can either enhance or suppress yawn contagion, depending on whether the stress increases social attention or creates defensive withdrawal. Temperature, lighting, and air quality affect both spontaneous yawning and contagious yawning, suggesting that environmental conditions modulate the behavioral energy states that make contagion possible. The cultural variations in yawn contagion reveal how social norms can influence biological physics. Some cultures discourage yawning in public settings, potentially reducing transmission opportunities and altering natural contagion patterns. Social contexts that emphasize group cohesion and conformity show stronger yawn contagion effects, while individualistic environments may suppress behavioral synchronization. These cultural modulations demonstrate how social energy conservation can be enhanced or inhibited by behavioral norms and expectations. Have you ever been in a quiet room when one person yawns and suddenly everyone around them starts yawning like dominoes falling in slow motion? Or noticed that just reading the word yawn or watching someone yawn on TV makes you feel that irresistible urge to yawn yourself? What if I told you that contagious yawning isn't just a quirky social phenomenon, it's actually your brain demonstrating one of Emmy Noether's most profound insights about energy conservation applied to human behavior in ways that reveal the hidden physics of social connection? Today, I'm going to expose how your mirror neurons are operating like biological resonance systems, transmitting behavioral energy across human networks with the same mathematical precision that governs vibrating strings and synchronized pendulums. The phenomenon is so universal and immediate that it seems almost magical. You're sitting in a meeting, lecture hall, or waiting room when someone yawns. Within seconds, other people start yawning, often without consciously noticing the original yawner. The effect can spread across a room like a wave, jumping from person to person in patterns that follow predictable mathematical rules. You might even be fighting the urge to yawn right now just from thinking about yawning. This isn't coincidence or suggestion, it's physics in action, demonstrating how behavioral energy propagates through human networks according to conservation principles that Emmy Noether would recognize immediately. To understand why yawning spreads like a contagious frequency, we need to explore the physics of mirror neurons, specialized brain cells that fire both when you perform an action and when you observe someone else performing the same action. These neurons function like biological resonance systems, similar to how tuning forks vibrate in sympathy when exposed to matching frequencies. When you see someone yawn, your mirror neurons literally recreate the neural patterns associated with yawning in your own brain, triggering the same physiological and behavioral responses as if you had initiated the yawn yourself. Emmy Noether's insights about symmetry and conservation laws provide the key to understanding why this neural mirroring occurs with such reliability. The human brain maintains behavioral energy conservation. The neural patterns that govern actions like yawning exist in dynamic equilibrium states that can be disturbed by external inputs. When you observe someone yawning, that visual information creates a symmetry-breaking perturbation in your brain's behavioral energy landscape, forcing your neural system to restore equilibrium by executing the same behavior. It's not conscious mimicry, it's unconscious energy conservation. The physics of yawn transmission follows remarkably predictable patterns that demonstrate conservation principles at work. Research shows that contagious yawning spreads most effectively between people with strong social bonds, family members, close friends, romantic partners. This isn't because of emotional connection, it's because repeated social interaction creates synchronized neural networks that resonate more efficiently. People who spend time together literally tune their mirror neuron systems to match each other's behavioral frequencies, creating optimal conditions for energy transmission. The timing of contagious yawning also reveals underlying conservation mechanisms. The delay between observing a yawn and executing a responsive yawn averages about 60 seconds, with a range of 30 seconds to a few minutes. This delay corresponds to the time required for mirror neurons to process visual information, activate motor pathways, and overwrite competing neural signals. The consistency of this timing across different populations suggests that yawn transmission operates according to fixed neural physics rather than variable psychological factors. But the phenomenon extends beyond simple behavioral mimicry to demonstrate sophisticated energy conservation. Yawning serves multiple physiological functions, regulating brain temperature, increasing oxygen intake, stretching facial muscles, and modulating alertness levels. When one person yawns, they're responding to specific physiological conditions that likely exist in others sharing the same environment. Contagious yawning ensures that groups maintain synchronized physiological states, conserving collective energy by coordinating arousal levels, attention patterns, and metabolic responses. The social physics of yawn contagion reveals fascinating patterns about how energy flows through human networks. Yawning spreads more readily from high status to low status individuals, following social hierarchy gradients that mirror how energy flows from high potential to low potential states in physical systems. Leaders and dominant personalities act like energy sources, while followers and subordinate individuals function as energy sinks, creating directional flow patterns that optimize group coordination. Research into artificial systems that can trigger contagious yawning explores whether technological interfaces can effectively stimulate mirror neuron responses. Virtual reality environments, robotic systems, and computer animations that display yawning behaviors can sometimes trigger contagious responses, but typically with reduced effectiveness compared to human yawning. These findings suggest that optimal behavioral energy transmission requires the full complexity of biological motion and social cues that have evolved over millions of years to facilitate group coordination. The therapeutic applications of understanding yawn contagion physics are beginning to emerge in clinical settings. Therapists working with autism spectrum disorders use yawn contagion tests to assess mirror neuron function and social responsiveness. Researchers studying empathy and social connection examine yawn transmission patterns to understand how behavioral energy flows between individuals with different neurological profiles. These applications demonstrate how fundamental physics principles can inform medical understanding and treatment approaches for conditions affecting social interaction. The mathematical modeling of yawn contagion networks reveals complex dynamics that mirror other energy transmission systems in physics. Computer simulations show how energy propagates through social networks, following paths of least resistance determined by relationship strength, proximity, and individual susceptibility. These models can predict contagion patterns in groups and help explain why some social environments facilitate stronger behavioral synchronization than others. The workplace implications of yawn contagion physics extend to understanding productivity, team dynamics, and group performance. Open office environments that facilitate visual contact between workers may inadvertently create conditions for enhanced behavioral energy transmission, leading to synchronized fatigue states that affect collective productivity. Meeting rooms where participants can see each other clearly may experience stronger yawn contagion effects, potentially indicating when group attention and engagement levels need restoration through breaks or environmental changes. The educational aspects of contagious yawning reveal how classroom dynamics involve behavioral physics. Teachers who yawn may inadvertently trigger student yawning, potentially indicating when learning environments need adjustment for optimal attention and engagement. The direction and intensity of yawn contagion in educational settings can provide real-time feedback about group alertness states and the effectiveness of instructional approaches. The digital age has created new frontiers for understanding behavioral energy transmission as video conferencing and virtual interactions become more prevalent. Researchers are investigating whether yawn contagion effectiveness differs between in-person and digital interactions, and how screen size, resolution, and audio quality affect mirror neuron responses. These studies may reveal fundamental principles about the sensory requirements for optimal behavioral physics transmission. The next time you find yourself yawning after seeing someone else yawn, remember that you're not just following social suggestion, you're demonstrating Emmy Noether's conservation principles applied to behavioral energy in human networks. Your mirror neurons are functioning like biological resonance systems, maintaining symmetry and conserving energy across social connections with mathematical precision. Contagious yawning reveals that human behavior follows physical laws just as predictably as vibrating strings or synchronized pendulums, showing us that the boundaries between physics, biology, and social interaction are far more porous than we might imagine. In the simple act of synchronized yawning, we glimpse the profound ways that energy conservation governs not just physical systems, but the intricate social networks that define human experience. This is just one example of how Emmy Noether's revolutionary insights about symmetry and conservation continue to reveal hidden physics principles operating in every aspect of your daily life. From the batteries in your pocket to the behaviors in your brain, from the crystals in your salt shaker to the social connections in your community, the same mathematical laws that govern galaxies and subatomic particles are actively shaping your reality in ways you never imagined. If you're fascinated by discovering the hidden physics that controls your everyday experiences, subscribe and join our community of curious minds who are learning to see the universe through Emmy Noether's eyes. We're exploring the secret mathematics of reality that most people never notice, revealing how conservation laws, symmetry principles, and energy physics govern everything from your morning routine to your deepest social connections. Each video uncovers another layer of the hidden science operating all around you, transforming ordinary moments into profound revelations about how the universe actually works. Hit that subscribe button and ring the notification bell because we're just getting started on this journey to decode the mathematical secrets hiding in plain sight. The physics revolution that will change how you see everything is waiting for you. Don't miss out on discovering how Emmy Noether's genius continues to illuminate the deepest mysteries of existence, one everyday phenomenon at a time.